Hey guys, and welcome back to a new Jetpack Compose video. In this video, I want to really give you a much deeper understanding of how Jetpack Compose recompositions work, how we can optimize certain recompositions, and why sometimes that is actually something that we should not do at all. So before we get started here with this, a big disclaimer. Please, after having watched this video and after probably knowing much more in regards to optimizing recompositions in your Compose UI, please don't just go to your projects and implement all the things you've learned in this video. With this video, I primarily want to highlight how tricky Compose recompositions can be and what you can do to remove some and sometimes even all of them. But it's important for me to say that what I show you here does sometimes require quite some adjustments of your code that then harms your overall code quality and how understandable your code is. Maybe you know this already, premature optimization is the root of all evil. If your Compose UI is running smooth, you're not having any performance issues, then please don't focus on improving performance if you don't have any noticeable issues, okay? I mainly make this video to give you a deeper understanding of how Compose works under the hood, and in case you do really run into performance issues, so you really have a laggy UI and you've tried a lot of other things, then these are things you can take a look at and you can try out, okay? Great. I have prepared a little sample UI here of Jetpack Compose. So we have a bunch of people here inside of a lazy column, and for all of these, we can load additional details. If we click on load details, then we get some simulated loading progress here, and we just load more details for this particular person. And this works for all people here individually. And as you can tell, there are quite some UI updates here, especially for the progress that we show here. There are many updates happening here per second. So we get this fluent progress update. And there are updates where we just show our loaded bio together with the phone number here in exchange for our load details button. Let's take a look at how this looks like in code, because I really chose a very common type of architecture here that I also personally promote in my videos and courses. So very commonly, you have some sort of screen state class, so simply a data class in Compose that bundles your entire screen state. In this case, it's a loading state. This is just for showing an initial loading indicator, also simulated here, this one. And after that, after a 3-second delay, we show all of our people here, which we then get from this people list instead of our state. This people list consists of person UI elements, so simply person details, but together with all those details that have an impact on the look of our UI. So you can see ID, the name, whether we're currently loading the details, the specific loading progress. This is a float value that regularly gets updated when we click on load details here. And those details that will be non-null after we have then loaded these, of course, all with sample data. So this is our simple setup here for our UI. This state is then kept in a viewModel reference. Up here, you can see just inside of a mutable state flow, default state. We then expose the public immutable state. This onStart operator is really just to load the initial data. This is my preferred way of doing it. I have another video about that, so don't want to deep dive into that in this video. And down here, we have one action. So these typical intents from MVI, where we just bundle each single user action inside of such a serial interface. In this case, what a user can do on the screen. So loading the details, clicking on the load details button for a particular person, passing in the ID to the viewModel, and then we load these details, and that really just simulates this loading progress for a particular person. And then we, of course, also have our UI. So here we have our people screen root, where we observe the state from the viewModel, and then just pass it down, so we don't need to pass down the viewModel reference to the people screen, since that would break the preview. And I, first of all, want to show you the current state here, together with the layout inspector. So we open the layout inspector, which helps us to track down recompositions and know which composable recomposes how often. We can expand this entire hierarchy here to see all of our composables and all these list items. And if we now click on the load details button for person 2, for example, you can see there are a lot of recompositions. Specifically, if we take a look here, our people screen root, so the entire screen together with the people screen composable, recomposed 101 times. The lazy column recomposed 101 times. And if we take a look here at this particular person item, this, so the person item for which we clicked load details, that also recomposed 101 times. So a lot of composable functions are being called again here. And this is now what I want to optimize step by step. But again, I want to still show you this. We can load the details for a lot of these people here individually, and we still get a very fluent UI. So here it's not a problem. This is really just meant to demonstrate what you can do if you really have performance issues and to understand how Compose treats certain parameters and values on a deeper level. And one last thing before we take an actual practical look at these things, today is the last call, the last day when you can join the Mobile Dev Campus for the relaunch discount. This discount expires in 12, 16 hours from when this video comes online. And then all the prices will rise again. So if you join, you get access to 30 plus hours of video material. You get access to coding challenges for app development, mini challenges, community access. You can ask me and my team any Android question when it comes up to really boost your learning. If that sounds good to you, check the link down below. As I said, discount expires today. And now let's take a look here in our UI, what we can do. So you saw that a lot of our UI actually recomposed, and you actually might think that all these recompositions should be there, that there is no way to optimize these out. Because in the end, our person to item that we clicked on was constantly being updated. Here, if we click load details, this loading indicator here is updated many, many times a second, so we get this fluent look of this progress indicator. But that's actually not true. And in order to understand that, you need to understand the 3 different phases of Compose. Or in other words, the 3 different phases of a single frame in Compose. What Compose will go through for each frame, or at least phases Compose can go through. It can decide which ones it may skip, but it can go through these 3 phases. On the one hand, composition. That is the phase where Compose decides about the actual hierarchy, so the UI tree, how your UI looks like. Compose will then go through the layout phase. This is where it decides where your composables are actually positioned on the screen, how big they are. And lastly, the drawing phase. The drawing phase is really what gives your composables the look they have. So what really draws the real raw pixels on the screen. And what many people don't know is that only changes in the composition phase require recompositions. It's already in the name. So only if your Compose UI changes in structure, that should cause a recomposition. When does it change in structure? For example, here, if we take a look at the when expression, when the state is loading, we show a circular progress indicator, and otherwise a lazy column. So if the state now switches from loading to not loading, we suddenly change something about the structure of our UI because we swap out a composable with another one. So our resulting UI tree is a different one. And that causes a recomposition. But changes in regards to layout, so where your composables are positioned on the screen, and changes in the look of your composable, for example, the background color, these don't necessarily need to cause recompositions. Because if, for example, the background color of a composable changes, then Compose only needs to re-invoke the draw phase. Since the structure of your Compose UI stays the same, so it doesn't need to compose everything again, it only needs to actually redraw a certain composable on the screen without actually rearranging certain elements. And that, by definition, does not need to actually cause recomposition. However, here comes the catch, it still can if you have a certain structure and types of parameters in Compose, and that's what we'll get into now. If we take a look in this person item, then down here, we actually make use of this linear progress indicator, that is the material 3 composable, that already implements this type of look that we've just seen here with this loading indicator. And the interesting thing is that it takes a progress lambda. So it doesn't take in a progress parameter as a normal float, but it takes it as a lambda that returns a float. And the reason for that is exactly what I mentioned. If we pass down a compose state as a lambda that returns this compose state, then this lambda can be used, in this case here, in a canvas that is under the hood used here in this linear progress indicator. I'm not sure if we see this. Yes, here we use a canvas. And what is inside this canvas is now not a composable function anymore. This is now what Compose will actually re-invoke when the draw phase is actually being called again. And you can see here, this course progress is actually being called. So you can see progress lambda, course progress just put inside of the correct range. And here, inside of the non-composable function that simply draws the contents of this progress indicator on the screen, here the lambda is invoked. But since it's invoked outside of our composition, so outside of a composable function, Compose can re-invoke this canvas function here completely independently of the actual Compose UI hierarchy. And that's why we first of all pass down this one here as a lambda. But even though we do this, Compose still recomposed very often, as you've seen here. And the reason is simply, if we take a look at our people screen, here where we pass down our parameters to our person item function, the person and this lambda, well, if we take a look at when recompositions actually happen, they happen if a parameter a composable function uses changes. And if we think about what happens if we update the progress of a particular person, well, here in our people screen state, we have our person UI, we have our details loading progress, this float. When that changes, we create a new instance of this person UI element with a new updated progress, and that just happens quite frequently. So with every little progress update, we get new instances of this person UI, and this person UI is then being passed to each list item here in the lazy column. And since one field of this person UI element changes, Compose also considers this whole person as possibly changed, because this composable may definitely need the changed field here of this person element, and that's why this person composable will first of all recompose. So the first step that we could do here in order to at least have the first step of our recomposition optimization is that we go up here, and rather than passing down the entire person UI, we pass down individual fields of that. So we pass down a name, we pass down the details, and we pass down is loading details. So a Boolean, whether we're currently loading the details. And lastly, we pass down the progress lambda here. So rather than actually creating the lambda here in our code, in our person item composable, we want to create this as early as possible and then pass down the lambda while making sure that the return value of the lambda can change, so the progress changes, but the lambda itself should not change, because if the lambda changes, it would cause a recomposition. I know this is very complex, and unfortunately there's not really a simple way to explain this, but it will make all more sense the further we go in this video. So we now want to take those new fields and simply update these here, because we don't have this person UI element anymore, but just those other parameters that we've passed down here. So here now, where we actually pass the lambda of the person.details loading progress, we rather want to pass down our progress right away without wrapping it in a lambda, because it is already a lambda. Okay, let's actually relaunch this and take another look in the layout inspector. Okay, here we of course also need to adjust this. We need to pass down the name here. We say person.name. We say the details is person details. We say the progress. Here we now wrap the lambda and we say person.details loading progress. And is loading details as person is loading details. Let's relaunch this once more. And then we take a look here. There we go. We are loading our elements. We can also open the layout inspector already, extend our hierarchy here, and we now click on person 2. And we still get all those recompositions. Why is that? Well, if we take a look here, this particular person item also definitely recomposed very often. So that itself did not fix anything. And we can actually also see with Compose why a certain composable is recomposing. So if we go in here and we actually debug our app, so we don't launch it normally, but we debug it, and then after having composed the very initial list, we put a breakpoint here to our column. If we then click load details, so a recomposition of this person item would be caused, then we can actually see, if we click this again, why this composable recomposed. So these yellow arguments, those were the ones that changed and that caused this particular recomposition. And if we take a look here, our name did not change. Well, the person's name was the same. Details didn't change. Is loading didn't change. But those two lambdas, they actually did change. So that means these two lambdas, on the one hand, the progress lambda, but also the onload details lambda, was recreated. And that new lambda instance caused a recomposition, since it was technically a different parameter. So what can we do about that? Well, the reason why Compose behaves this way is whenever we update our progress in the view model, as I said, then this float value here of our specific person UI class changes. This definitely causes this items block for that particular item to be re-invoked. And then here, Compose will actually take a look which of the parameters have changed compared to the previous recomposition. And the name did not change, as we've seen. The details did not change, as we've seen. And well, the details loading progress did change. And that is the reason why Compose actually created a new lambda reference. It is important to understand that lambdas are compared based on reference. So even if we have two identical lambdas, where we say we have one person details loading progress, if we have such a lambda and we would compare this with another lambda that is identical, this would actually be false because they are compared based on reference, and this is a different instance than this. So what can we do about that? We can make use of a Compose effect handler called remember updated state. So what we can do is we can actually get the progress and we say by remember updated state. And in here we pass in our person. Oh, it's actually must be inside of the items block, of course. Person dot details loading progress. This is now a float value. So not a lambda or float, but if we now pass in this float value here, we relaunch this. Take a look here at the layout inspector again. We extend this, we click on person 2. We can see all those recompositions of our screen, of lazy column, and here also of our person item. If we open the debugger again, and let's remove this breakpoint for now. We open the debugger and we see why this composable is recomposing now. We put the breakpoint there now. Load details, click this once more. This time, for some reason, it does not mark these in orange, but we can also take a look at the debugger tab here because the blue elements now changed. And if we take a look at this recomposition state, then we can see the name is unchanged, the details are unchanged, is loading details is unchanged, the progress is unchanged. So our progress lambda is now considered as unchanged from compose because we made use of remember updated state. But the onload details lambda, that still changed, and that lambda was now what caused the recomposition. But before we fix that, let's understand what remember updated state actually achieves here. In the end, remember updated states helps us to kind of freeze the lambda reference. So it prevents that this lambda is recreated over and over again when the progress changes, but it still achieves those functions inside of this composable here that read the value of this lambda, so that invoke this lambda, that those composables always get the updated state, so the most up-to-date progress state, which then references this person's details loading progress. So we just achieved that the lambda instance here is not recreated, but the value that the lambda returns is still kept up to date with this value here. And that's exactly what we want here. However, if we now take a look at this onload details click lambda, then it seems like whenever our progress changes, this lambda is also recreated, even though it's kind of static. So we just invoke our onAction lambda here. We call onload details click. We pass in our person's ID. So why is this lambda recreated? Well, this lambda also wraps a certain compose state, or at least a part of a compose state, which is this person. And since something about that person changed, the lambda could have possibly also changed, and compose recreated this lambda. Since compose doesn't know that our IDs by definition can change. So with every change of any field in the person class, compose will also recreate this lambda. And a recreated lambda is a new instance. Compose will see, okay, this lambda is actually a different one than the previous one, so I better recompose since something about this person item might have changed. However, we know that nothing will change if this lambda is going to be recreated, since it always does exactly the same thing. We can now fix this by remembering the person ID. So we can say the ID of the person is equal to remember person dot ID. And we use this without keys because we know that our ID will never change. So we can remember it across recompositions. And if we now take this person ID and we pass it down to this lambda, person ID, then this lambda also won't be recreated anymore because it does not use any state from compose that could have changed, because it sees this person ID, but it sees, okay, remember, there are no keys, so there is no way that this person ID actually changed, and therefore there is no way that this lambda actually changed. So if we now relaunch this, open up the layout inspector, open up our hierarchy, and click load details, we still see a bunch of recompositions, but if we scroll down to our person item, suddenly this person item now only has 2 recompositions. Remember, previously it also had something around 100. So while we still have a lot of recompositions here to work on, these 98, 99, 99, our actual list element now only recomposed twice. So we reduced this by almost 100 recompositions here, just by remembering this person ID and using this remember updated state here for our frequently changing state. So you see how tricky this actually is to optimize something like that in Compose. Even though technically it's possible to not have recompositions for something like this, where we have a loading indicator, actually achieving this in practice is still a different thing if you have a rather complex state. However, we are still not where we want to be. So why actually is our people screen root recomposing or people screen our lazy column? Well, if we take a look, that comes because we wrap our entire compose state in a data class, actually here. So our entire screen state is put in this data class. This comes from a state flow in our view model here. And in our Compose UI, we simply listen to the state. And whenever this state actually changes, then this composable function collect as stable lifecycle will recompose technically, will re-emit a new value. Therefore, this function must be re-invoked since the state value has changed. This state value is then passed down to the people screen, which sees, okay, something at least about the state has changed because the state is a new instance now. So the people screen recomposes, and inside the people screen, Compose now has the option to see, okay, which parts of our people screen are actually using a part of the state that has changed. This is now the point where Compose can say, okay, certain composables don't need to recompose because the value they've referenced did not change, even though the state itself changed. And if we really want to optimize those recompositions, that news is a little bit harder and requires restructuring your state a little bit. The good news is that these types of recompositions are rarely really a performance issue. Because even though, if we click on load details, our entire screen flashes and there are so many recompositions, it seems like at least, you must imagine that a recomposition in the end is just an extra function call. And if the majority of your Compose UI is skipped, which is the case here, so these gray numbers are the skip counts. Those are composable functions that Compose decided to not call again because they did not reference a value that changed. So if really only that specific child composable of your hierarchy recomposes that should recompose, those screen recompositions here are really just function calls. Just because there is a big screen flashing doesn't mean this recomposition is worse than a different recomposition. Because in the end, we compare two function calls here. And what Compose shows here as this blue flash, that just shows the area of the composable that recomposed. But even if the screen would just have the area of 1 pixel, the recomposition would be just as heavy CPU-wise, okay? But I still want to show you how we can optimize this. Again, here the disclaimer, this is something that I would be very careful with in real projects since it now harms the overall code quality a bit. Here in this case, it will still all be understandable because it's not a super difficult example, but in real apps, you have more complex state like that. In the end, the reason why we still see those compositions here is because something in our people list changes, and Compose can't individually track those items that have changed. And the solution to this problem is to take our state, take this people list, and extract that into a separate Compose state list. So a list where Compose can track each and every single item and when it changes. So we want to remove this people list here from our state, go inside of the view model, and rather introduce a private, let's say private val people. Say this is a mutable state list of, so a mutable list of compose states, of snapshot states, that is the technical term, specifically of person UI elements. That's what our list consists of. And then we expose public list, that is just a list of person UI that is not mutable. And then we say when we get the underlying people list when we call this element. But that way we can't directly mutate this list from the UI. And now we of course need to update all those places here in the view model where we actually update those people. So here we would say people.clear and then, people.add all dummy people. So that's just a static list that I have assigned here. For loading the details here, previously I mapped all those existing people. In this case, we can update those a little bit differently. Because we have a mutable list, we can access a certain element at the index we want. So we can find the index of the person that we want to load the details for by just saying that's equal to people index of first, where the ID is actually the same ID that we've passed here. And then we can say people at the index of our index is then actually equal to the same person, but we copy it. And we say the details loading progress is 0f, and the is loading details boolean is true in this case. This replaces that piece of code, and we can then actually copy this because we need this call here again when we listen to each progress update. Here, we want to make sure that we update our progress. And lastly here, when the flow completes, so when we actually loaded a person's progress, then in that case, we want to say we assign those details here and we set the loading value to false. Now we did that, we expose our state list, our snapshot state list. In our screen, we now need to listen to that individually. So actually we don't need to do this here, but we want to pass this people list now as a separate parameter. So Compose can also take a look at this parameter here separately independent of changes of the state class. So here we want to say people is equal to viewModel.people. We make sure we add this parameter. People is a list of person UI. And then here where we reference data.people, we just reference our people list directly. Down here for the preview, we have some issues. We don't need the preview here anyways. So let's remove this, relaunch the app and take a look at what the layout inspector tells us now. There we go. We are loading our entries, still connecting. We extend this. If we now click load details, oh, okay, that is looking a little bit better. Our screen is not recomposing anymore. Our composable did recompose. But what if I tell you that these two recompositions that we see here are actually only because our compose structure changed? And that's what I mentioned before, that changes of our UI structure cause recomposition, and that's totally valid. So if we think about it, the moment we click load details, the load details button is swapped out with the progress bar. That is a structural change. And the moment we fully loaded a person's details, we also swap out the progress bar with the actual details. So with this bio here and with this phone number. But you will notice if we actually increase the delay here a little bit so that the progress is simulated a little bit longer, let's say we make this 200 milliseconds and we relaunch this, you will notice something very, very interesting. Here we can extend this. If we now click load details, you can see it flashes once, but now for the entire duration where our progress indicator is actually expanding, there are 0 recompositions. Nothing in our UI is currently flashing because of exactly the reason I've mentioned. That is because we pass down the progress state as a lambda. And this is also called deferring the state read, because we try to actually read the value of this progress state as late as possible. Specifically, if we take a look here again, in our linear progress indicator, we try to read the state only here inside of the draw scope of the canvas, which is not a composable function. So if this lambda is reinvoked, this has no impact on actual recompositions of our remaining UI. And the same is true. The same is the case if you maybe want to change the position of an element, if you want to rotate an element, if you want to animate an element from the top left to the top right corner. These types of things where you have movements on the screen, where you transform an element, that does not need to cause recompositions because a different phase of compose is involved. In this case, the layout phase. In our example, it was the drawing phase. And only if your state change really causes a structural change of your compose UI, that should cause recompositions. But again, once more, what we did here is we effectively broken down our state, which is a bit against this pattern. And with this state here, it's still pretty clear, but imagine your state is way more complex than that. Maybe you have some kind of lists of data classes that maybe also may have lists. It becomes harder and harder to split down such state. And then it becomes worth thinking about whether you actually stick to this single state, which I think is actually a very clear and consistent approach, since everybody knows how to structure state in your project, or whether you say, hey, every single field of my state should be its own compose state, and I put it as a single state field here in the view model. Then you have a bigger view model on the other hand, but you are more flexible when it comes to optimizing such recompositions. I would just be a little bit careful with such hybrid approaches where you do it like this sometimes and sometimes like this. If you're using such data class UI states, like I also still do in my videos, I still love this approach more than flooding my view model with single state fields, then what I showed you in this video is something to keep in mind if you run into issues and if you notice that the recompositions are actually what causes your UI performance to drop. There is still a lot more what you can do in order to optimize your UI performance, in order to make your lazy columns smoother when scrolling. And these are things that I would try first. Optimizing recompositions is one of the hardest ways to optimize your UI performance. It can definitely help, but you've seen how tricky this can be. And this video surely also did not cover all types of recompositions that can happen. If this is something you want to dive deeper into, then check out my Jetpack Compose Masterclass course. I will also link this down together with a mobile dev campus. As I said, today the discount runs out. If you're interested in hearing such tips on a daily basis, if you want to take part of the technical discussions with me, with my team, with other cool committed Android developers, and just participate and really practice your coding skills with practical coding challenges that we provide, Figma mockups for you that you can then practice with immediately without having to think about all those other things that just distract you when it comes to deciding what to work on for a hobby project. Check it out. Other than that, thanks so much for watching. I will see you back in the next video. Have an amazing rest of your week. Bye bye.